Welcome. This is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. And this is Exploration. Every week on Exploration, we discuss the fascinating world of science and its impact on society. And once again, I'm going to answer some of the emails that I constantly get. I can't possibly answer all of them. However, I will try to answer some of them on air. Well, let's just jump right into some of the emails that I get and some of the questions that I get. First question concerns SpaceX. How close are we to the commercialization of outer space? Well, it turns out that SpaceX, the firm started by Elon Musk, the billionaire, it turned out that this year was a banner year for that organization. Rocket after rocket sailed into outer space and, more important, came down as scheduled. These are reusable rockets. Rockets whose boosters are not simply jettisoned over the Atlantic Ocean, never to be seen from again. No, these rockets take off like a conventional rocket. The upper stages then fire away. But the booster rocket has its own retro rockets that allows it to slow down and land on a platform. This is a dream come true, and SpaceX has done it a number of times. It's not just a fluke. They've demonstrated the capability of commercial organizations like SpaceX fielding a very complex infrastructure, allowing them to send rockets to the International Space Station and then bring them back. This could answer one of the key criticisms of the space program, and that is the question of cost. It costs roughly $10,000 to put a pound of anything into near-Earth orbit. That's your weight in gold. So why not have a rocket that is reusable, thereby reducing the cost of space travel? Well, after several successful launches, it's inevitable, Elon Musk suffered a major setback when its rocket blew up spectacularly on the launch pad. However, we should also point out that there's a lot more at stake than just the fortunes of SpaceX. You see, back in 2013, it looked very bleak for the space program. The space shuttle was canceled. The replacement for the space shuttle, the Constellation, was canceled. The moon program was canceled. And the Mars program was also canceled. And our astronauts, our red, white, and blue astronauts, had to thumb rides on Russian booster rockets to get up to the International Space Station. This was humiliating. President Barack Obama said that we have to inspire young people because of the legacy of Sputnik. However, it's hard to energize young people about the age of Sputnik when you cancel Sputnik and you cancel the manned space program. Well, to be fair, President Barack Obama also said that we have to rely on private enterprise to pick up the slack. And Elon Musk is an example of what President Barack Obama was talking about. That is using, not taxpayers' money, but using investors' money now to field a galaxy of rockets that can take payloads into outer space. In fact, Elon Musk is even more daring. He announced that in just 2 more years, he expects to send the first unmanned rocket ship to Mars. I mean, think about this. This guy's an entrepreneur. He's a billionaire. He uses his own financing and the financing of investors to shoot rockets to the International Space Station, and now he wants to go to Mars. Just realize that only a handful of nations have been able to reach Mars, and here's an entrepreneur saying that he not only is going to send an unmanned space probe to Mars by 2018, he may also entertain the idea of spending a manned mission to Mars even before NASA does. What's the game plan? The game plan here is that Elon Musk wants to create a 2-planet civilization. He believes that it's simply too dangerous to put humanity on just one planet. He wants humanity to flourish on at least 2 planets, and that is Mars and the planet Earth. Because, according to the laws of physics, the Earth is doomed. Ice ages, meteor impacts, super volcanic eruptions, not to mention the death of the sun itself. All of them are mandated by the laws of physics and geology and astronomy. So, at some point, we're going to have to leave the Earth. It's not a question of if, it's a question of when. Either we adapt, we flee, or we die. That's the law of evolution. Realize that over 99.9% of all animal species have perished on the planet Earth. Most species never make it. And the question is, will Homo sapiens be one of those 99.9 species that simply don't make it? Just remember that the dinosaurs didn't have a space program. And that's why they're not here today, because they didn't have a space program. Well, we do have a space program, and out of self-interest, I think it's good to take the few steps toward becoming a two-planet species. And speaking about two-planet species, are there planets out there that have intelligent life forms on them? Well, in 2015, last year, a signal was detected. Finally, astronomers released the information to the public, freaking people out, and that is we might have detected the first signal from an extraterrestrial civilization. In fact, the signal was so strong that only an advanced civilization could have sent that message. So in other words, the internet was set abuzz with the news that perhaps there's an advanced civilization out there wanting to make contact with the planet Earth. Well, let's look at the facts and look at the speculation. The signal came in at 11 gigahertz. It came from the constellation Hercules. It was picked up by radio telescopes based in Russia, and it did seem for a while that this was an anomalous signal that could not have been natural. It must have been extraterrestrial. However, now the Russian radio telescope installation is beginning to backtrack a bit now. It's beginning to say that, well, there's always a possibility it may have been of, quote, terrestrial origin, unquote. In other words, probably an airplane, probably one of our own satellites. Who knows? But it leaves open the opportunity that it was not an intelligent, advanced civilization in outer space. It was just a satellite or a jet airplane or any number of possibilities that are of, quote, terrestrial origin. We should also point out that last year, yet another signal was picked up. It was a signal that seemed to be periodic, and it seemed to, again, come from outer space. Scientists were skeptical, so they tracked it, and it turns out that it came from a microwave oven. Yes, somebody opened a microwave oven and could duplicate that signal. And we also, of course, have the famous wow signal. Back in 1977, when the search for extraterrestrial civilization just began, radio telescopes picked up a wow signal, much more powerful than the signal picked up from the constellation Hercules, but it was never seen from again. It just disappeared, no matter how many times people have looked for a repeat of the wow signal. You see, science is done on things that are testable, reproducible, and falsifiable. So if you claim to have been abducted by a flying saucer, well, maybe you were, but maybe you weren't. It's not testable. It's not reproducible. It's not falsifiable. Therefore, all we scientists can say is, maybe, but maybe not, because there are other possibilities as well. So I tell my friends that if they have ever been abducted by a flying saucer from outer space, for God's sake, steal something. I don't care what it is. A paperweight, a pencil, a paperclip, a chip, any alien technology, so you can have bragging rights afterwards saying, see, I was abducted by a flying saucer, and here's the proof. Or if the saucer people did forbidden experiments on your private parts, then why not show them alien DNA? That would clinch it right there. No ifs, ands, or buts. So there are many ways to clinching it, but they involve things that are testable, reproducible, and falsifiable. Simply saying that you saw something in your backyard, well, maybe you did see something in your backyard, but that's simply not enough proof. And speaking about anomalies on space, the Dyson sphere is still causing a certain amount of worries among astronomers. Last year, when scientists were looking at the eclipsing of a star by a companion object, most likely an exoplanet moving around the star, they find that usually starlight dims by about 1%. So let's say when Jupiter moves in front of our sun, a distant civilization in outer space would say that the sunlight from our sun dipped by almost 1%. Well, here's the problem. There's an object out there 500 light years from the planet Earth, and its starlight dimmed by 20%. This was shocking. This is incredible. Jupiter, the biggest planet in our solar system, can only dim starlight by 1%. What can possibly dim starlight by 20%? Well, people rattle off all the usual suspects, meteors and comets and dust and all sorts of things, but they eventually gave up. The best they could come up with is very feeble, maybe, quote, a comet storm, whatever that is. That may be responsible for it. But most astronomers have simply shaken their heads and said, we don't know. Well, of course, the science fiction buffs are out there, and they say, well, maybe it's a Dyson sphere. Maybe it's a technology of a Type 2 civilization, a civilization thousands of years ahead of us, capable of building an object bigger than Jupiter, capable of harvesting all the energy from the mother sun. Well, of course, we can speculate all we want. We still don't know the answer. We're simply waiting for the next recurrence. Because if something happens, it must be reproducible. That's the key to science. And so scientists are waiting for that star to have a dimming of starlight. It's happened twice so far. It's off the charts in terms of a phenomenon for which we have no plausible explanation. Think about that. Also, the shock waves from the discovery of Proxima b is still reverberating through the halls of astronomy laboratories. As you recall, astronomers announced that they got it. They hit the jackpot. And that is, they found the holy grail of planetary astronomy. And that is to find the closest Earth-like planet to our planet Earth. In other words, a doppelganger of the planet Earth in outer space. Well, the closest star to the Earth is Proxima Centauri. You can't get any closer than that. 4.2 light years from the planet Earth, and bingo. And bingo. Astronomers found a planet going around Proxima Centauri. They called it Proxima b, and it indicates that, yes, it is Earth-like, and there could be many planets just like Proxima b in our galaxy. The latest estimates are between 50 to 100% of the stars we look at in the galaxy have planets going around them, many the size of Jupiter. However, about 20%, roughly 20% of the stars you see in the Milky Way galaxy have Earth-like planets going around them. This, of course, is astounding. It means there could be a billion Earth-like planets in our Milky Way galaxy. More than a billion. It staggers the imagination to think about this. But this is the latest scientific evidence coming from the Kepler satellite. Now, because of the discovery of the closest Earth-like planet, all sorts of people are now jumping on the bandwagon, trying to figure out, well, is there life on Proxima b? What would it look like? And maybe, is it intelligent? Can we communicate with them? Well, let's try to break this down one by one. What have we found is that there's a planet 30% larger than the planet Earth, whose distance from the mother star is such that it could plausibly have liquid oceans. We don't know for sure, but the oceans on this planet, the hypothetical oceans, are not going to boil away because the planet is too close or freeze because the planet is too far. In fact, the planet is just right from the mother sun to have a stable liquid ocean. But we don't know if there's water on that planet. We don't know if it has an atmosphere. We don't know if it has oxygen. That'll take more decades of hard work using what are called spectroscopes to analyze the radiation coming from the planet to see whether or not it is Earth-like, that is, has an oxygen atmosphere and liquid water oceans. Well, that hasn't stopped people from speculating, well, what do they look like? Well, because the gravity is only 30% stronger than the gravity of the planet Earth, they may actually be rather human-like. In other words, they'll probably have some means of locomotion, tentacles, legs, appendages, whatever. But they'll probably have three characteristics which made us become intelligent. First is stereo eyesight of some sort. We have two eyes, not because we look handsome or pretty because of that. We have two eyes because we have stereo vision, the vision of a hunter. Hunters are smarter than prey. That's why we say smart as a fox and dumb bunny. Foxes have to zero in on the prey. That's why their eyes are at the front of the face. Think of a lion, a tiger. Think of animals that eat other animals, and you realize that all of them have eyes at the front of their face in order to log on to the prey, hide, camouflage, ambush, and then chase after the prey. However, if you're a dumb bunny, all you have to do is run. All you have to do is have eyes to the side of your face, like deer, because then you have 360-degree vision, and you can see the predator coming your way. And after that, all you have to do is run. So chances are, even though, of course, we're not positive, chances are intelligent life will be descended from predators. Hopefully, they will have ironed out their differences with other life forms, so they don't want to eat us. We're probably not going to be made out of the same DNA, but more than likely, they will be descended from predators. Second, we have an opposable thumb, which allows us to manipulate the environment. A tentacle, a claw might work, but our thumb is very good at manipulating tools. And then we need a language in order to hand down information from one generation to the next generation, in order to hunt communally, share information and discoveries. Now, let me ask you a question. How many animals do you know of? Think of all the animals that you know. How many animals that you know of have stereo vision, some kind of opposable thumb of some sort, and some kind of language by which to hand down information generation to generation? And you may say to yourself, oh my God, the answer is basically none. Or maybe perhaps some of the primates come close to that. Perhaps they have a primitive language. Perhaps they're not as dexterous as we are, but they can just about wield a tool. And yeah, they have stereo eyesight, the eyes of a hunter. Well, you begin to realize something very quickly, and that is the animals in the forest, the animals in the ocean, are simply not equipped to evolve into intelligent species. Now, this has rather interesting implications. It means that maybe we have, first of all, overrated intelligence. Maybe we have overrated it, thinking that nature strives to create intelligent beings, when actually there are thousands and thousands of creatures on the planet Earth that do just well, all of themselves, without being intelligent at all. So on one hand, you can draw the conclusion that maybe intelligence is overrated, that it's not necessary to be intelligent to survive in the forest. I mean, think about it for a moment. If you were to be stripped down so that you have no clothes, and you were to be thrown into the snows of, let's say, New Jersey, into the forest there, how long could you survive? And what about animals that do survive just well, foraging in the forests of New Jersey when it's snowing? And then you begin to realize that, well, yeah, maybe intelligence has been overrated. But then you have another conclusion as well, and that is maybe intelligence is so precious that it took 4 billion years to get intelligence off the ground. I mean, think about it for a moment. We're looking for Earth-like doppelgangers in outer space, but we already have a twin, and that is ourselves. Our Earth is Earth-like. Duh. Of course our Earth is Earth-like because it is the Earth. And how long did it take for intelligent life to get off the ground of the planet Earth? Well, we've been around for about 100,000 years or so. The Earth has been around for 4.5 billion years. And so then you learn something rather remarkable. And that is perhaps intelligence is so precious, so extraordinary, that it took 4.5 billion years for intelligent life to get off the ground on a planet that is Earth-like. That is the planet Earth itself. Well, also speaking about biology, let's say a few things about Alzheimer's disease. Many people think that Alzheimer's disease could be the disease of the century. We have the aging baby boomers. We have the fact that the population of China is aging. Population of Japan is aging faster than any other nation on the planet Earth. Europe is aging. And it means that we could have an epidemic of Alzheimer's disease. In fact, in Japan, for example, in the suburbs of Tokyo, you have whole areas out there in the suburbs where 20% of the homes have been abandoned. They're almost like ghost towns. Young people are fleeing into Tokyo. The old people out there are suffering from Alzheimer's. They're retired. They can't move out. They can't move to Tokyo. It's too expensive for them. And when they die, the kids simply throw in the towel. They throw away the key and abandon these homes. 20%, incredible, 20% of some of the suburbs have been abandoned because the people living there are mainly the very elderly, the retired, and people afflicted with Alzheimer's disease. In fact, if you watch Japanese television, you realize that there are special after specials about Alzheimer's disease and its effect on the Japanese population. Well, after many false starts, we have now the first little bit of good news. Amyloid protein gums up the brain. Whether it's a cause or a symptom of Alzheimer's, we don't know. There have been many attempts to clear out this amyloid gum that clogs up the brain, and finally we have a candidate. It was only been tested on less than 200 people, but it does seem to clear up the amyloid proteins. And again, this is the first ray of hope, the first glimmer of hope in trying to contain the Alzheimer's epidemic. Much research still has to be done. You cannot rely on just 200 people, not to mention the fact that perhaps there are other reasons that the brain comes down with Alzheimer's disease and dementia. But let's face it, this is the first good ray of hope when it comes to reining in one of the deadliest killers of modern times, and that is Alzheimer's. We should also point out that there is a competing theory. The competing theory says that it maybe it's an infection of some sort that causes inflammation, and that these Alzheimer's plaques are a defense mechanism by which the body uses to try to encapsulate the virus or the bacteria. Well, even if that rival theory is true, clearing out the amyloid protein still may be a good thing, because according to this theory, the body overreacts. The body overreacts to this infection by creating massive amounts of amyloid protein to encapsulate and imprison these viruses and bacteria. Sort of like our autoimmune diseases when the body overreacts and begins to destroy itself in the form of arthritis, lupus, and any number of autoimmune diseases. But time will tell. Time will tell whether or not we finally have at least the glimmer of a hope against Alzheimer's. Well, I'm afraid that's it for the first part of Exploration. And in the second half of Exploration, we're going to talk more about medicine. We're going to talk about the promise and perils of biotechnology. And with us today is one of the leaders in that field, a very young gentleman who's already made his mark. We're going to talk to Robert Lanza, and we're going to talk about the promise and perils of one of the greatest discoveries of our modern times, and that is the ability to play with our genes. So stay tuned now for the second half of Exploration. Welcome. Once again, this is Dr. Michio Kaku, Professor of Theoretical Physics at the City College and the Graduate Center of the City University of New York. In the second half of Exploration, we're going to talk about inner space. That is the space inside our bodies. The revolution that was set off by the Human Genome Project, the revolution of biotechnology that has changed the face of medicine. In fact, medicine today is just totally different than what it was before the Human Genome Project. With the Human Genome Project, we can actually understand how medicines work. We can understand how the body is put together. We can understand how germs attack the human body. And it's causing a tremendous revolution in medicine. And it's also in the news. For example, the Zika virus. Already, scientists have sequenced the genes of the Zika virus and are preparing a counterattack, perhaps vaccines, perhaps genetically engineered mosquitoes that are sterile. All sorts of different kinds of ideas are being tried because of our knowledge of biotechnology. But let's not be naive about this either. There are going to be enormous sociological implications of biotechnology as well, not just cloning, but also the ability to manipulate our genetic heritage. What does it mean if you can eliminate a gene from your family tree forever? Perhaps a gene that causes disease, or perhaps a gene that's eliminated purely for cosmetic reasons. And we all saw the Olympics recently, and in Brazil, the Olympics Committee is already worried about how genetic engineering may shape the athlete of tomorrow. We've already found the Mighty Mouse gene. Now we've found the Schwarzenegger gene that allow people to bulk up genetically. And so in the future, are you going to pay good money to see a baseball team knowing that the winner will simply be those that had better geneticists and better ability to manipulate the genes for muscle and coordination? Anyway, all sorts of implications are raised by biotechnology. So with us today is Dr. Robert Lanza, one of the leaders in this field, who will talk to us about the implications of the biotech revolution.
Well, as a young boy, I was rarely allowed outside the house, so I was on my own, and I went to the ponds to catch snapping turtles and would climb trees to catch screech owls and flying squirrels. And so I'd go on these long trips trying to figure out the universe. And even at that age, I was in awe at the world. But unfortunately, my parents and none of my sisters had finished high school, so I too was placed in this slow class with the kids that used to throw the spitballs. So I came up with this plan.
I know that.
Yeah. So I came up with this plan to prove myself, and actually at that time, Watson and Crick had just cracked the genetic code just a few years earlier. So I decided to carry out what amounts to genetic engineering.
As a kid?
Yes, I was actually a teenager. I was around 14. And I had actually seen a black squirrel, and so I wanted to see whether I could make it albino or vice versa. And so I went to my biology teacher, and he told me that it was impossible, and everyone laughed at me. But I was determined to prove him wrong, so I went into my basement, and I figured out actually how to alter the genetic makeup of a white chicken to make him black by transferring genes from the pigmented chicken. And my mother thought I was just trying to hatch chicken eggs. So I decided, to really prove this, I really needed to work with someone who understood that stuff. So, to me, the greatest place on the planet was Harvard Medical School. So I saved up my nickels and dimes and took the buses and trolleys into Boston. And it actually took me half a day to get there. I didn't even know where I was going. So I tried to go in through the front door, and the guard didn't let me. It was sort of like Dorothy in The Wizard of Oz, when the palace guard said, "Go away." But rather than leaving, I went around the back and I waited by the Dipsy dumpster, and I saw this little short, bald guy walking up with khaki pants and a bunch of keys. And I thought, oh, here's the janitor. So he opens the door, and I just sort of slip in. And a little way down the corridor, he says, "Well, can I help you, sir?" And I said, "No, I'm looking for a Harvard doctor." Now, what I didn't know was that was Stephen Kufler, chairman of the neurobiology department. He had just been nominated for the Nobel Prize.
Is that right?
Yeah, so I thought that he was just the janitor, and so I told him that I was friends with the janitor down the street from me, and that I worked in the cafeteria. And so he asked me why I was there, and I said I was trying to alter the genetic makeup of a white chicken, and then I went on explaining about DNA, thinking he doesn't have a clue. And then he actually said, well, I know someone that can help you. And he brought me upstairs, past all the spaghetti wire and all to Josh Thanes, who now runs actually the Brain Center at Harvard. And he was just a grad student at the time. So after talking with Josh all day, they invited me back to repeat those experiments. And the work was ultimately published in Nature in 1974. And every now and then I would go back and the janitor would show up, and I was always so excited to see him. And it wasn't until later that I realized who he was. So that was actually how I got into the hard science.
And where did you get the equipment for your high school project interfering with the genes of living organisms? Where did you get your equipment?
Well, it was really very challenging. You have to remember I was just a little boy, very short. I didn't look very old. And, I'd be trying to get syringes, so I'd be at the hospitals trying to convince the doctors to give me syringes. And then I would go to another hospital and convince them to give me penicillin. And there was actually a gentleman who actually worked at one of the state labs who had a centrifuge in his cellar. So I put these all together and managed over a period of time to figure out how to do it in a very crude way.
So you created your own biotech laboratory in your basement?
Yeah, right next to the furnace. My mother actually had no idea I was doing it.
Amazing. When I was a kid, I built an atom smasher in my garage.
You're kidding.
I had to go to Westinghouse.
So you understand.
Yeah, I went to Westinghouse to get 400 pounds of transformer steel and 22 miles of copper wire to build a 2.3 million electron volt Betatron in the garage. And you, as a kid, was out there meddling with the genes of living organisms.
Yeah, I mean, it was a fun time.
Okay. Well, moving on now. Let's talk about cloning. We've heard so much about cloning in the media. Arnold Schwarzenegger even had a movie where he met his clone, and the whole movie was based on criminal clones. Well, what is a clone, and how far are we in terms of being able to clone animals, primates, and maybe even humans?
Well, cloning is conceptually very simple. You basically take the cell from the animal you want to clone and put it next to an empty egg that has had all of its DNA removed. And then you send an electrical charge through the two cells, and they fuse. So when the cells fuse, the DNA from the cell you want to clone is dumped into the empty egg. And another approach is just to inject the DNA directly into the empty egg. The next step is to use chemicals then to fool that egg into thinking it's been fertilized. And so then this cell starts to divide, and you end up with an embryo that can then be placed in a surrogate mother. And then if everything goes well, you can end up with a genetically identical copy of the animal you want to clone. And, of course, we've cloned at this point many dozens of species. We've cloned endangered species, glow-in-the-dark mice, whole herds of cows. In fact, there have been many farm animals, goats, pigs, cows, and even pets such as cats and dogs.
Now, we had a chance to interview Ian Wilmot, the Scottish scientist who actually cloned Dolly. Explain to us exactly what he did. What was Dolly, and was Dolly premature age? There was some controversy about that.
Well, yes, Ian Wilmot was the first to actually clone a mammal from an adult cell. And so he actually took a cell and went through the methodology I just described, and then that DNA was placed into an empty egg from another sheep. And when Dolly was born, everyone thought, because of the length of the telomeres, and these are the ends of the chromosomes that determine how many times a cell can divide, we all thought that cloning basically, Dolly was basically an older sheep, in disguise. And so what we actually did is published a paper in 2000 that actually showed that wasn't the case, that you can actually start out with an old senescent cell that's decrepit, and the cloning procedure actually restores that cell to a youthful state and allows it once again to start dividing into an entire organism. So it actually turns out in the end, using not only just sheep but also cows and mice, it's been shown repeatedly now that in fact cloning is like a little time machine. You can actually rejuvenate that DNA and actually end up with youthful cells.
So in other words, you are literally turning back the biological clock, resetting it back to zero when this clone is born.
Absolutely. In fact, in some of the experiments we did, we actually were able to turn it back even more so that the cells actually had twice the lifespan that they normally should. So again, the process is very irregular, so there's a possibility that, that they may actually live shorter or longer, and a lot of that depends on many factors.
So, in other words, the cloned animal, in some sense, may actually be an improved version of the original animal with longer telomeres?
Well, certainly at the cellular level, we know that that is the case. Now, obviously aging is very complex. There are other environmental factors that go into it. But certainly at the cellular level, we know that in some of these experiments, we actually have cells that lived quite extensively longer.
Okay. Now, what kinds of animals have been cloned? I understand that pets have been cloned, and I even went to Dallas, Texas with the film crew from BBC Television, where we went to a ranch where we saw clones of clones of clones. And one series of animals, we had like 8 animal calves all lined up in a line. They were all identical twins. So what kinds of animals have been cloned?
Well, the list is quite extensive, starting from mice, rats, and rabbits, again, all of the various farm animals, goats, pigs, horses. In fact, we created an entire herd of cows that actually was making human proteins in their milk that were genetically modified. On top of that, of course, there are multiple different endangered species that have now been cloned. So in theory, virtually every mammal should, in the future, be able to be cloned.
Now, in the newspapers, every once in a while, some oddball announces that he's done the first human clone. However, as I understand, no primate has been successfully cloned. What's the status with regards to cloning primates and humans?
Well, as you point out, cloning primates, including humans, has been problematic. Back in 2001, we were actually the first group to clone the first early-stage human embryos, and we were doing that for generating stem cells, not for reproductive purposes. And even to this date, the technique isn't perfected. Of course, there was the Wong scandal where for a while we thought that someone had that technique worked out. In fact, just a few months ago, we published a scientific paper where we showed for the first time that human cloning can't actually successfully reprogram human cells back to a normal embryonic state, and we're still working on that.
Now let's talk about your work, which is nothing less than fantastic. First of all, with endangered animals, you've been able to essentially bring back to life, genetically speaking, organisms that have been dead for 25 years. Explain your work.
Well, as you know, about 100 species go extinct every day, and those genes are lost from the planet forever. And so seeing that we're the ones that cause most of these extinctions, a while back I thought that, well, perhaps, we had some responsibility to see if we could use some of our tools the best we can to reverse that. So back in 2000, I actually decided I would try to clone a gaur, which is an endangered ox-like creature from Asia, and it had been hunted almost to the verge of extinction. And I actually got some cells from an animal that had died a few years earlier, and tried to clone it using ordinary domestic cow eggs. And many of my colleagues said that, well, Bob, that's impossible. You can't get a clone. You can't clone one species using the eggs from another species. And it turned out we actually were able to generate a beautiful little baby gaur embryos. We actually sent them off to Iowa by FedEx Overnight Express, and they were implanted into ordinary farm cows. And 9 months later, we got a baby gaur, which we called Noah. It was born alive, walking around and bellowing. But then a couple days later, it died of dysentery. So everyone said, see, Bob, it doesn't work. So I went back to the San Diego Zoo and convinced them to, let's give this a try again. So they said, well, we actually have this, what we call stud 391, that died back in 1980, a quarter of a century earlier. And he said, it would be great if you could bring that animal, resurrect that animal, so we could reintroduce that valuable genetic material into our highly inbred group of animals that they had. So they sent me a vial of these cells, and we transferred them into some empty cow eggs, and they were sent off again to Iowa and implanted in some beef cattle that served as the surrogate moms. And we started with 16 pregnancies, and 9 months later we were down to just 2. And so there we were back in 2003. We were secretly gathered out in this farm out in the middle of nowhere, and we were watching this cow give birth by C-section. And I remember, when they started the C-section, there was some splatting of blood, and the vet reached in and pulled out from the mother's belly, these 2 small hooves. And when they started to massage it, suddenly its eyes opened and its ears started to wiggle, and it let out this big bellow, and everyone applauded. And the whole thing was so surreal. Here we were out in a farm in Iowa watching a beef cow give birth to this exotic endangered animal that's normally born in the bamboo jungles of Southeast Asia. It was really exciting.
Now, since then, I guess many other people have followed in your footsteps, right? So I guess many endangered animals have been brought back.
Yes, that is correct. And just recently in South Korea, I understand that they cloned an endangered wolf. The hope is we've actually been in dialogue, with some folks in China about the giant panda. But also, too, work is now going on to clone cheetahs and even the extinct Bukato mountain goat.
Now, I understand that the competition is so fierce that in South Korea, one of their leading researchers was tempted to commit fraud and basically faked all his papers, claiming these fantastic results. Could you elaborate?
Yeah, actually, back at the early part of this decade, we actually, there was an article on the cover of Wired where we were on the verge. We actually had cloned a pretty advanced stage human embryo. And at the time, everyone thought it was imminent that we were going to be publishing, actually creating stem cells. And then just out of the blue, this group in South Korea, which no one had any knowledge of, published a paper in Science saying they had done it. So obviously, this individual thought he could do it, and his name was Wong. And unfortunately, it turned out many years later that the whole thing had been fabricated. It was just a complete disaster. It actually, terminated most of the research we were doing. Everyone had just assumed that this feat had been accomplished. It was one of the biggest scandals in scientific history. It was just terrible.
And in fact, some of my colleagues were wondering why he did it to disgrace the whole country, because at some point it would come out. However, the leading theory is that he probably thought that some group around the world was going to do it anyway, so why not simply beat them out by a few months to a few years, and then people will forget. People will overlook things and not go into the details and find out that he was a total fraud.
No, absolutely. I know he was convinced that in a few months we were going to publish a paper showing we could do it, and then everyone would say, see, it works. And then he would have gone on and got his Nobel Prize. And in fact, the government gave him millions and millions of dollars and then literally thousands of human eggs. And so I'm sure he was certain that he would be able to achieve it, and no one would ever know. In fact, he pulled into his group, some of the top cloning experts in the world, Shatton and even Ian Wilmot in the end was working with him. So I'm sure he figured out with all of the brain power and resources that this would be pretty simple to do. And as you know, it's turned out to be a lot more difficult than anyone thought.
Now, let's talk about something that is science fiction,
okay.
Bringing back extinct animals, including the Neanderthal.
Mm-hmm.
On this show, we've had people that are very interested in sequencing the genome of the Neanderthal, our nearest species, which died out tens of thousands of years ago in Europe. And believe it or not, they expect the full genome of the Neanderthal to be sequenced in the coming years. And there's talk about maybe bringing back the Neanderthals. Any comments?
Yeah, I think that, on many of these, extinct species, including the Neanderthal and dinosaurs, that at some point in the future we may have that technology. I think, even today, I know, like, for instance, when you come to my house, I have this 6-foot Brontosaurus bone that weighs 800 pounds, and it's from one of the largest dinosaurs that ever roamed the earth. And the first thing everyone asks me is Bob, are you going to clone this? And I tell them, you can't clone from stone. You need living cells, or certainly the tissue. And as you mentioned, once we have the genome, we may be able to incorporate that into a living cell. Now, the thing to remember is that it's a little more complicated than that, because there's 2 genomes in the cell, the mitochondrial genome, and that has to talk with the nuclear genome. So that presents a bit of a problem, because even if you have the DNA for the species itself, what determined you, or the Neanderthal or the dinosaur, you still need to figure out how to get that to be able to interact with the maternally transferred genetics. So again, I always say that you're not going to be seeing dinosaurs in your backyard anytime soon. Again, the Neanderthal tissue, as well as the mammoth that was unearthed a few years ago, you have to realize that after years of freezing and thawing, that there have been holes poked in the animal's DNA. And right now, molecular biologists don't know how to fill in the gaps. And the same thing applies, I think, to the Tasmanian tiger, which died out in the 1930s in Australia. But I think someday we are going to learn how to either sequence the entire genome or to repair the DNA. But again, that's going to be many years off.
Now, with the woolly mammoth, we've actually had several people involved in that project on exploration, and they tell me that if you extract DNA from the carcasses of these animals that died thousands and thousands of years ago in Siberia, you just get fragments, little pieces here and there all over the place, and it's pretty hard to make sense out of it. However, with computers, we're going to get very good at putting pieces together and having the computer put the jigsaw puzzle together. So what do you think? Maybe one day a computer using what is called bioinformatics, do you think they may be able to piece it together using, let's say, a blueprint of an elephant genome?
I think absolutely. I think we have a lot of tricks in our toolbox, something known as homologous recombination, which would allow us to go in and splice the genes right in precisely where we'd like them. And there are some newer techniques evolving. And then, of course, you would require a very powerful computer, seeing that I think someone once compared it to shredding up the New York phone directory into little pieces and then having to reassemble it. But with computers, as you know, they're very powerful, and we're discovering new tricks. So I think sometime in the future, yes, that we definitely should be able to do this.
Now, about 2 months ago, I did a book tour in London, and I went to Oxford. I had dinner with Richard Dawkins, one of the leading biologists in the world, and he's on record as stating that perhaps one day we'll be able to take the genome of a human, compare it to the genome of a chimpanzee, analyze the genes that are different, and then with a computer program, interpolate between them in order to get the best approximation for the genome of the missing link, Australopithecus. Now, of course, he says this is an outrageous idea. He's very careful to say that, but it's an idea that can't be ruled out. You have any thoughts about such an outrageous idea as one day bringing back not just a Neanderthal, but the missing link?
I think all that is possible in the future. There's no question about it. Once we have the tools to manipulate the genetics, already today we know how to knock out genes, for instance, to increase the muscle mass of an animal to twice its original amount. So I think we already have some of those tools, and we're adding them very quickly. So yes, I think it could be done, but as you mentioned, I think there's this ethical concern that it will probably prevent it from occurring. I mean, even when we, generated the first cloned embryo, even for medical purposes, I mean, it was a huge outcry. It's very, very controversial. So, yes, in theory, I think we will eventually have the scientific tools to do it. The question will be, should we?
And speaking about ethics and the dark side, maybe you saw the movie The Island. In that movie, it's a very dark plot. People find out, much to their shock, that they are actually clones of a real person. They didn't realize that they were imposters. They always thought they were real humans, but they were cloned in order to harvest the organs of their body. In other words, they were raised to be killed so that the organs of their body could be harvested and then given to a rich man who actually paid big bucks to have their body cloned. Now, of course, you can't clone memories. That's not possible. But do you think that is the way some people are going to go, or do you think we'll simply grow organs separately from having to clone the entire body?
Yeah, well, I think there's a consensus in the medical and scientific community that you would never allow any kind of a clone to go past the first several days of cell division. So it would be smaller than, the head of a pin. So I think what we would do is what we're doing now is you would create embryonic stem cells, or what we call now iPS cells for pluripotent stem cells. And those cells are immortal and they grow, and we can now turn those into virtually every cell type in the body. And through a new techniques that are developing in a field known as tissue engineering, we can reconstitute those into more complex tissues and structures. In fact, I published a paper with Tony Ataller a number of years ago where we actually used a cloned cells from a cow to create, actually to grow in the lab, kidneys that actually were able to remove toxic materials when we transplanted them back into the animal they were cloned from. And those cells were very smart. They had assembled into the glomeruli, into all the various elements of the kidney. And since that time, work has been done to grow in the lab entire bladders that have been used in patients. And in fact, there's work now where people have actually created primitive beating hearts using this tissue engineering technique. So one day you're going to go to the hospital, we'll take a skin cell, and we'll just grow you up a new kidney or whatever you need.
And speaking about that, I went with a film crew from BBC Television down to Wake Forest University, where you're also a professor. Mm-hmm. And we actually went through Tony Atala's laboratory, where we photographed heart valves that are opening and closing, heart valves that were grown from your own cells. Mm-hmm. So now we can grow bladders. The first windpipe was grown recently. Now, where is it going to go? Are we going to be able to grow, for example, a liver? If that happens, think of all the people who die because they don't get a liver in time, like Mickey Mantle, the great baseball giant, died of liver failure. Mm-hmm. Is the liver, the pancreas, are they coming?
Absolutely. We're making enormous progress on tissue engineering virtually every organ system in the body, including bones and tendons. And also, too, we're now on the forefront of what we now are able to do is to actually a new paradigm in medicine where we're able to actually generate early developmental cells that only exist transiently in the embryo and use them to repair the adult body almost like nanoparticles. So, for instance, we published a paper a couple of years ago where we created what we call these hemangioblasts, and they were like ambulance cells. And when we injected them into the body, we found that in animals that had had massive heart attacks, that it actually cut the death rate in half. A simple injection. Or in animals where, for instance, they would otherwise have their legs amputated due to lack of blood flow, we completely restored the blood flow by injecting these cells. In the same manner, the liver, we believe we have cells that will be able to repair that. So I think in the next few years, you're going to see a lot more of this work published. And yes, I think you're going to be able to repair virtually any worn out or dysfunctional tissue in the body.
Well, I'm afraid that's it for Exploration. Once again, this is Dr. Michio Kaku for Exploration. Good day.